So we started today with just an introduction about what ratios are and how you see them in rational numbers. So going back to the beginning today, and we start here, we started off with trying to find what word you see in the word rational, and eventually you guys saw this word ratio. And a ratio is just a comparison. All a ratio is a comparison of two numbers. So we counted in class today to find the ratio of girls to boys. We had 2 girls and 7 boys, and we can write that ratio 3 different ways. We can use the word 2, 2 to 7, or we can use the colon symbol, which in mathematics means the word 2. So this says 2 to 7, and that means we have 2 girls for every 7 boys. But the most common way we write ratios is looking like a fraction. This is not a fraction though. A fraction is a special ratio that's part to whole, and this is not showing part to whole. We had 2 girls for 7 boys. So the ratio of girls to boys, it looks like a fraction, but it's read differently as 2 to 7. And then if I change it around and said, what's the ratio of boys to girls? Then we have to give the boys first, and that would be 7 to 2. And then one person wanted to know, when you just see a number like this, like 3/4, how do you know if it's 3 to 4 or if it's the fraction 3/4? And you'll know by whatever the situation is. If the situation is about ratios, you'll know it. If it's about fractions, you'll know it. In general, if you just saw this, you would think it's a fraction. So it just depends on what you're studying at the time. So all ratios and all rational numbers have something in common, and they're just all comparisons, and they act like fractions. So today we practice changing each of these red numbers into a fraction so that we can give it as a ratio, but it looks like a fraction. You have to know what the ratio is comparing. So if I just have the number 0, it's really comparing 0 to 1. So you put 0 over 1. It looks like a fraction, but this is the ratio of 0 to 1. The integer negative 12 is negative 12 to 1. If there's no other number, then it's those negative 12 for every one. Maybe it's the number of euros owed by each person. 25% is the ratio of 25 to 100, because percent means out of 100. And some of you knew that that's the same amount as 1 to 4. So 25 to 100 is an equivalent ratio or an equal ratio to every 1 to 4. Written like this, 5 to 7, written in fraction form, 5 to 7. Now 4 and 6/10 is 4 and 6/10 to 1, but when you give a ratio, you don't want to have a decimal in the numerator. So to get rid of that decimal, we just have to multiply by 10. But if we want to keep an equal ratio, what we do to the top, we have to do to the bottom. So 4 and 6 times 10 is 46, and 1 times 10 is 10. So this ratio, 4.6, is really 46 to 10. 7 is 7 to 1. 3.5, well, you've got to change this mixed number into a fraction. Remember, ratios act like fractions, so it's 7 to 2. Really, we're just doubling 3.5 and doubling the 1, so it's 7 to 2. And this decimal is read as 200, so you put 2 over 100. So then we practice today, how do you tell what fraction is equal to this decimal? Well, we reviewed the place value, and what you have to be able to do is to read this decimal, and then you write what you hear as a fraction. So I read this decimal as 3/10, and to write that as a fraction, it's 3 over 10. So as a ratio, it's also 3 to 10. You read this as 36 hundredths, because if I look at 0.36, the 6 is in the hundredths place, so that's 36 hundredths. So I put 36 over 100. And if I have 0.367, I read that as 367 thousandths. So I put 367 over 1,000. And I gave you a resource page that you can use as a tool to help you practice that. So then in your table groups, you practice changing each decimal to a fraction. When you read this, it's 57 hundredths. When you read this, it's 936 thousandths. As a ratio, it's 936 to 1,000. 2 and 1/10, you can think of 2 ways. You can put 2 and 1/10 over 1 and then multiply them both by 10, so you get 21/10. Or you can think of this 2 and 1/10 as looking like this, 2 and 1/10. and then change this mixed number into an improper fraction, so it's 21/10. And then you read this as 46,281 hundred thousandths, and you write what you hear as a fraction. And then we just talked in class about why can you never have a 0 in the denominator of a fraction. And we went back to an example that you guys know how to check your division with multiplication. So if 6 divided by 2 is 3, we always check that by saying 3 times 2 is 6. So if we have two groups of 3 and it equals 6, then 6 divided by 3 is 2 and 6 divided by 2 is 3. So we always check a division problem by multiplying. So this is correct because 3 times 2 is 6. So if I want to divide 3 by 0, what number times 0 will give you 3? Well, nothing times 0 will ever equal 3 because anything times 0 is 0. So this is impossible. So you can never divide by 0. And in mathematics, we call that undefined. When you can't divide by, when something's impossible to do, we call it undefined. All right, and then we had a little bit of time to play the Big One game in our Fraper deck of cards. And those were the rules. And then for homework, you have a weird homework assignment. I normally do not do this, but because of your first quiz today, we were not able to finish this lesson. So I just want you to read through pages 17 to 20, take notes on any new vocabulary, and we'll go over this next class, but it's going to be easier if you've just read this first. And then I want you to practice the problems that relate to what we did to class. So they're on pages 21 to 22. Do 9 through 12, 15, 19, and 25 to 28. And this is one of those rare times when there is not a different challenge assignment. And it's because we didn't finish the lesson. And that's it.